Good morning. I am K. Palnivel, Assistant Professor, SNS College of Technology, Coimbatore. Today, going to the topic, a case study on subwatershed data using cubic spline. Abstract: watershed erosion reveals spatio-temporal variability and determines sediment yield, which is a key to appropriate watershed management, considering several curve numbers as nodal point in the domain. In this paper, we have constructed the approximate curve using cubic splines corresponding to the sediment yield index. The aim of this construction is to predict sediment yield index corresponding to any arbitrary curve numbers lying in the domain to construction. It is observed that cubic spline show a satisfactory performance with NAS efficiency of 61.36%. We have established the quality of approximation by comparing the given value with the approximate value of sediment yield index at a certain nodal point and noted that these values are quite closed. Introduction: the erosion may be defined as the detachment and transportation of soil. The major agent responsible for this erosion in many locations, winds, glaciers, etc., also soil erosion. The watershed planning and management highlights the management techniques to control erosion in the catchment watershed area. Due to lack of data availability, estimates are made by means of prediction models that evaluate soil loss or sediment yield separately. Osler's proposed an empirical relationship between sediment yield index and area and delivery ratio. A different approach proposed an empirical relationship between delivery ratio and morphological characteristics of catchment, such as catchment area, average relief, or slope. These models are popularly employed because of their simplicity and easily available data. The common experience that the sediment yield largely depends on the rainfall generated runoff, which in turn releases on the parameter curve number of a soil conservation service curve number methodology. The larger the CN value and larger will be the sediment yield in agricultural watersheds and vice versa, since CN represents the runoff producing potential of a watershed and sediment yield index the potential of sediment yield. It is quite logical that these two parameters, which SYI and CN, should exhibit some relationship between them. Study area and data source. Narmada is the largest west flowing river to the Indian peninsula. It is one of the important rivers of India. This river is 22,040 degree north in longitude and 81045 inch east in amplitude. The supervised land use and land cover. The supervised classification has been used in the study for classification of satellite data. The land use cover classes were agricultural land, fallow, barren, open land, water body, and forest. Area occupied by each land use were determined. Narmada watersheds have a good forest cover and agricultural land, agricultural and barren land. Maximum of 65.45% area is covered with agriculture in Manont watershed and 59.03 forest Bahmani. Soil map of study area is generated with the aid of NPSS slope map. The areas under different soils were identified. After analysis, it was found that the area of all watersheds fall under the hydrological soil group B. Soil group field from the soil theme and the land use field from S. Digital elevation models were generated from the SRTM data. Investigation also under two slope categories, gently and moderately sloping. Finally, going to the conclusion, the cubic spline is developed between SYI and CN using 11 slope watershed. The approximation is validated for sediment yield index for the remaining subwatersheds. Subsequently, high R2 values in this case study, the authors have verified that after computing the cubic approximation at some particular nodal points, the actual values of SYI are very close to the approximation values. Hence, we conclude that the approximation is accepted and the major advantages of this construction lies is getting appropriate value. Thank you for watching.